Good morning, children. Hope that you all are safe. Welcome to the fifth session of comparing quantities. Last class, we have learned about compound interest. As you know, it is the interest calculated on the principal and the accumulated interest of the previous periods of interest. Today, let us continue learning about compound interest. Time period and rate when the interest is not compounded annually. The time period after which the interest is added to the principal to form the new principal is called as the conversion period. When interest is compounded half yearly, interest is calculated 2 times in a year. So the time period, as you know, it is doubled and the rate is taken as half R, the annual rate. When interest is compounded quarterly, interest is calculated 4 times in a year. So the time period is 4 times. We write it as 4n. And the rate is taken as quarter. This 1 by 4 are the annual rate. Now, these are the formulas for calculating amount. When interest is compounded annually, amount is equal to P into 1 plus R by 100 the whole raised to n. Suppose the interest is compounded half yearly, amount equals P into 1 plus R by 2 by 100 the whole raised to 2n. When interest is compounded quarterly, amount equals P into 1 plus R by 4 divided by 100 the whole raised to 4n. Let us solve an example. Calculate the amount and the compound interest on rupees 10,000 for 1 year at the rate of 8% per annum compounded half yearly. Already we know how to calculate the amount in the case if it is compounded annually. Okay, but here you see the question is to calculate the amount and the compound interest when compounded half yearly. Let's see. So here the principal amount equals rupees 10,000. Rate equals 8% per annum. That means it will be 4% per half year. N is equal to 1 year. That means in 1 year we have 2 half years. Applying the formula, amount equals P into 1 plus R by 100 the whole raised to n. That's equal to 10,000 into 1 plus 4 by 100 the whole raised to 2. Making 4 by 100 in the lowest term, it is reduced as 1 by 25. Simplifying the terms inside the bracket by taking the LCM, 1 plus 1 by 25 is changed as 26 by 25. And that term is the whole square. So it is repeated 2 times. After calculating, we get the final answer as rupees 10,860. Now, to get the compound interest, that's equal to amount minus principal. Just now we got the amount as rupees 10,816 minus rupees 10,000, and that gets us the compound interest as rupees 816. Let us solve another example. Calculate the amount and the compound interest on rupees 1,800 for 1 year at the rate of 8% per annum compounded quarter. P equals rupees 1,800. Rate is 8% per annum. That means it will be 2% for each quarter. And in 1 year, we have 4 quarters. So the amount is given by the formula P into 1 plus R by 100, the whole raised to n. So that's equal to 1,800 into 1 plus 2 by 100, the whole raised to 4. The lowest term of 2 by 100 is 1 by 50. So it is changed as 1,800 into 1 plus 1 by 50, the whole raised to 4. After taking the LCM and doing the calculation, we get the amount as rupees 1,948.40. So the amount is equal to rupees 1,948.40. Let us now calculate the compound interest. Compound interest is equal to amount minus principal. It's equal to rupees 1,948.40 minus rupees 1,800. When we subtract, we get the answer as rupees 148.40. There are several situations where the formula for calculating the amount in compound interest can be applied. Let us see where it is and how we will do that. In situations involving an increase of growth, R is taken positive and the formula for calculating the amount in compound interest is used as it is. For example, it's the case when there is an increase in the population, or it can be the case when there is increase in the growth of bacteria in a culture. Let us see an example. The rate of growth of a certain bacteria in a culture is 2% per hour. If there were 2,50,000 bacteria initially, find the number of bacteria in the culture after 2 hours. Let us solve. Here, P is taken as the number of bacteria which was present in the beginning. That is 2,50,000. The rate is 2% per hour. And the number of hours we have to see is for 2 hours. So, let's continue. The number of bacteria after 2 hours equals P into 1 plus R by 100, the whole raised to n. It's an increasing case, so it comes as P into 1 plus R by 100, the whole raised to n. That's equal to 2,50,000 into 1 plus 2 by 100, the whole raised to 2. 2 by 100 we can cancel and express in the lowest term. It is changed as 1 by 50. Going for the LCM and simplifying, we get the final answer as 2,60,100. So the number of bacteria in that culture after 2 hours will be 2,60,100. Isn't it interesting that the same formula which we learned for amount we have applied in a practical situation? Now, there are some situations involving a decrease or depreciation. In that case, we take R as negative and the formula is modified like this. So, amount equals P into 1 minus R by 100, the whole raised to N. Ravi purchased a two-wheeler for rupees 75,000. Its value is depreciating at the rate of 10% per annum. Find its value after 2 years. So, here the thing is that if we bought a two-wheeler, its value is depreciating, that means decreasing uniformly at the rate of 10% per annum. So we just wanted to know what will be the value of the same two-wheeler after 2 years. So P is the initial price for which he has purchased the two-wheeler, that is equal to rupees 75,000 and the rate is 9% per annum. And he wants to know if the value of the two-wheeler after 2 years. So N is equal to 2 years. Value after 2 years is equal to P into 1 minus R by 100, the whole raised to N. Here you see in the place of plus it is changed to minus. Why that minus came? Because it is a case of depreciation. That's why the plus is replaced by minus. Now we substitute the values in the place of P, R and N. So the given thing is changed as 75,000 into 1 minus 10 by 100 whole raised to 2. We can express 10 by 100 in the lowest term, that is 1 by 10. Then take the LCM. Here we have to subtract. That's why it is changed. 1 minus 1 by 10 is equal to 9 by 10. And the answer of that has to be repeated twice. When you multiply and then you cancel the zeros, you get the final answer as rupees 60,750, which means the value of the two-wheeler which is brought for rupees 75,000 will be rupees 60,750 after 2 years. So these are the practical applications of the same amount formulas. So that's all for today. Revise the lesson, go through the portions, learn it thoroughly. Success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing. Wish you all a successful day ahead. Thank you, children.